Hi everyone, my name is Bubu Nyonyavo. I'm a senior software engineer in Adjust. It's a company based in Berlin, so yeah, that's where I'm coming to you from. Today, I'm going to be presenting on how to store 45 billion records. What do we do? So Adjust is a mobile measurement partner. Essentially, what we do is we help our clients track their best channels for ROI in terms of marketing. So clients will create campaigns and then put them on Facebook, Twitter, LinkedIn, TikTok, wherever it is that they want to market to people. And then we help them track how people are clicking this campaign links and how these campaign links are converting depending on the platform that they've put these campaigns on, and then we help them convert. We help them attribute who is most. We help them figure out which channel is most efficient, where they can spend their money, where they can deploy their more resources. So in order for us to do this, we process millions of requests each minute. We process about 52 million requests every minute. During peak times, we process close to maybe 60 million. But on average, this is what it looks like this is what it looks like in 24 hours. Um, in every request requires us to maintain some sort of state or requires us to query some sort of state data. And for us, we use Aerospike to maintain state, and this is where we query all the state data that we need. So each request will invoke an operation in Aerospike, and depending on what operation it is, we fetch some data, we write some data. Sometimes we write in batches, sometimes delete, and then we return a response for these requests. We keep about 45 billion device states in Aerospike, or 45 billion records in Aerospike. And this is only about half of it because this is only about the state of a device. We have repositories that have to do with engagements, we have repositories that have to do with other bits of data like settings and something we call tracker. And those are different clusters. But I'm not going to be talking about those yet. So yeah, we do process and store a lot of data. Now, this is a graph of all the data that we store. This is a Prometheus increase query over I think 7 days. And in 7 days, we run scan operations to be able to clean up our database. So at the height of it, when the scan operation has completed, you can see the 45.1 billion records result in the top right corner. If each of these records was 1 byte in length, that would be a total of 46 gigabytes. But in essence, the P50 size of each request is about 512 bytes. Some of it is as high as 3 megabytes, and some of it is as low as 2 megabytes. But P50 is around 512 bytes. So that is about 351.9 terabytes in total in terms of data. We store all of this data in logical three separate data centers around the world. Each data center has a cluster, an Aerospike cluster, which has about 64 nodes running on bare metal setup, um, running on a Gen 2 operating system. The hardware is about maybe 70 cores on average, 400 gigs of RAM on each node, and then about 16 terabytes worth of hard disk. Hard disk is NVMe or SATA SSDs. Each one of those nodes has two 10 gig network interface cards set up in a bond configuration to be able to provide 20 gigabits uplink. We have a replication factor of average 2.5 because we have a some namespaces that have a replication factor of 2 and some namespaces that have a replication factor of 3. All of this is set up in a rack aware configuration. I think this is something we are currently working on so that if a single rack goes offline, it doesn't send us into a tailspin by reducing the amount of servers that have to serve requests. We All of these three data centers are set up using a cross data replication. Um, this is a mesh active topology where a request that ends up in one cluster is sent to another cluster where it is backed up. So as much as we have a as much as we have a replication factor of 2, in each data center, cross data center sort of increases the number by the number of data centers that we have. So in essence, we have 6 records of each data and 2 being in each data center. Because of cross data center replication, we have to pay a lot of attention to latencies because if a request comes to one data center and then the next one goes to the next data center, if there's a high latency, each request is seen as a separate entity and it becomes difficult to build on top of this. It also becomes a problem when you have to fail over to another data center because if the latency is high, it means that not all the data would have been sent over for replication to the other data center. If you've worked with any distributed system, you might have come across a theory which is called CAP theorem, which stands for consistency, availability, and network partition. It is an attempt to it's a trivial attempt. It's an attempt to describe the desired operational modes of any distributed data center, which basically states that you can have 2 out of the 3 modes, which means you can have consistency and availability, but no without network partition. You can have consistency and survive network partitions, but you won't be very available. And you can have availability and survive network partitions, but the data won't be consistent. Now, network networks will fail, which means that partition tolerance is going to go out the window, and the only desired or the only operational modes that you can have in reality is consistency mode and available mode, because you can't control when a network rack goes offline. Maybe there's a switch that is broken, maybe your ISP have gone down, or maybe there's some construction works in the sea or on the roads that is going to take out a fiber line. So you are only going to be able to work with consistency modes and available modes. Aerospike allows us to have two of these operational modes, and we use them in for different namespaces for different reasons. So there are some sets of data where we require only where consistency is more is we place a higher premium on consistency than availability, and there are some namespaces where we place another a higher premium on availability rather than consistency. So in a consistent mode, your response you will get the latest response for every request, but it will be slow. And in an available mode, you will get fast responses, but there's no guarantee on the freshness of the data. Some of the database operations we perform include read and write. We write a lot more than we read because you would want to store each click, each impression that is sent to us for us to be able to perform our attribution operations. For this, we use the Aerospike client driver, which is actually intelligent. The client driver is cluster aware, and it will ship each request to the node that is the leader of a partition. This way, you can achieve distributed nodes and high throughputs by sending requests to only the nodes you need to send requests to. Aerospike stores indexes in. You have the option to store Aerospike indexes in memory or on disk, and because we use NVMe and SSDs, we take advantage of this to be able to store our secondary indexes on NVMe and SSD. If not, we'd have to pay a high price to be able to store the amount of indexes that we have in memory. So this is one thing I think Aerospike does sufficiently well to be able to help us take advantage of cheaper hardware. So this is a graph of some of the operations that we perform. Put is write, and we perform about 1.2 million write operations each second, each minute, and about 1 million operations, get operations each second. 2 million get operations each second. So we do get and then batch get. There are a couple of other operations that we perform, but those are on the low side. This is the this is the graph of the timings of all the requests that we perform. The 50th percentile, 50% of all our requests so far will take less than 500 microseconds. And for the vastness of the data that we query, or for the vastness of the size of the cluster, this is actually pretty impressive to be able to get results in less than 500 microseconds. Some other database operations we perform include scans. So Aerospike is a key value data store. So it's not possible to perform sufficiently. It's not possible to perform highly complex queries. And one of the complex queries we require for business is to be able to scan the entire data set and then figure out which data set is no longer relevant to us, and then delete those data sets. We do this to comply with um, clients forget me request. When an end user clicks forget me, when some clients leave us, we need to be able to delete all of those and all of their data and other maintenance operations. Scanning the entire cluster takes about 3 days, and it is a very slow and intensive process because you have to scan. It takes a lot of resources to scan. Luckily for us, Aerospike can help us prioritize scans lower than get and write operations to take advantage of the hardware and the speeds. So in essence, when a scan is in operation and a get request or a request comes in, the scan operation is sort of suspended or put on a lower priority while the scan and the read and the write request are saved. So this is when we scan Aerospike, this is a graph of the number of entries we scan each minute. You'll realize that there are about four colors in here, and scanning is very dependent on the hardware on which you scan. So if you scan on hardware that has a lot of resources, like the first two lines, the blue and the orange line, you get a lot of throughput compared to on a machine that doesn't have a lot of resources. So yeah, you can with Aerospike on the server, you can control how scans perform. You can, and these are three operations we use internally to manage the scan operations. You can set the number of threads the scan is allowed to use. You can set the number of records each scan is supposed to return, and you can set the the number of allowed single scans on the whole cluster, so that when you have multiple scan requests, you don't exhaust all the resources on the server. So let's talk about upgrades. Upgrading an Aerospike cluster is a very long and difficult task. You have to go through the client driver changelog and make sure that nothing in the changelog breaks any of the changes that you want to. Nothing in the changelog breaks any of your existing behavior, especially if you are going to be migrating across major versions. If you don't understand something in the Aerospike documentation or how something works, feel free to email the Aerospike guys. I know we do a lot, maybe because we pay for it, um, but they are very forthcoming on information and will help you resolve some of the issues you might have. Don't take anything that you don't understand in the documentation for granted, because it can easily snowball and bite you in the ass. So yeah, um, Aerospike gives us the fine grained controls we need to be able to manage our cluster to meet our requirements. And understanding all the configurations is key to be able to take advantage of this beast of a technology. Because some trade offs might take you one way and another trade off might take you the other way. So you should be very careful, and understanding them is going to help you run a very successful cluster. Yes, unfortunately, I can't take questions. So thank you very much. And that's all I have for today.